My name is Craig Carroll. I am the transit specialist for Eastern U.S. for GTP, and with me today as special guest is Stan Lowe, who's the IT division manager for ALBUQUERQUE Ride. What we wanted to talk to you about today, again, is building a better BRT with transit signal priority. Many of the folks on this call, many of the folks that we saw accept to join the call are in a variety of different roles within transportation, within the consulting engineering space, basically embarking on projects moving forward, and we felt this was a good, valuable use of time to review some of the applications in which transit signal priority can be used for bus rapid transit. Moving on to the next slide. Smart transit, essentially GTT's role in the smart city is not an all-encompassing role. We have a very good specialty of what we've done and what our expertise in, and basically falls into two categories or two areas. One is intelligent transportation, intelligent transit operations, the ability for vehicles to get specialized treatment through intersections. And we also have a similar application within the public safety space, and that is emergency vehicle preemption. And the good news about those two technologies, it's really giving a city priority control over vehicles traveling through intersections, and there are both public safety applications as well as efficient transit applications associated with it, but it does utilize the same infrastructure. So as you're looking at these, at going down this path of BRT and TSP, it has multiple applications that you can use with the same infrastructure. So that's really GTT's role in this space. Getting into the agenda specifically for today, we are going to be talking about essentially three different categories: the bus rapid transit basics, how transit signal priority affects bus rapid transit and how it adds to the effectiveness of bus rapid transit deployments, and then a handful of success stories. And that's why Stan Lowe is with us today as a guest speaker. He's going to talk a little bit about the ALBUQUERQUE Ride deployment that is being implemented as we speak down in Albuquerque. Core elements of rapid transit. Essentially, there's a number of different aspects to rapid transit. They can be done in a couple of different ways, and they're essentially a federal guide to how you put in a BRT, but they involve things like dedicated lanes, easier accessible stations, ticketing and fare collection in an organized fashion, and really having to put different service and operating plans in place for BRTs and standard local routes. Marketing and branding comes into it, and then priority intersection treatment, which is really what we're going to speak to more today. How do you look at, how do you implement a BRT by utilizing transit and traffic types of technologies? On the intersection side of this, there's really a couple of different treatments. One is you just have either median-based straight runs where there are no left and right turns, which gives vehicles, it eliminates the delays of left turns and right turns off of roads. You also have queue jumps, which GTT can implement queue jumps, but again, that gives vehicles favorable treatment over other traffic getting through intersections. And then pure transit signal priority, which is basically keeping buses up, letting speed buses up and getting them through intersections more quickly by granting them special treatment at an intersection. Some of those special treatments are, again, it basically approaches a signalized intersection. On the next slide, goes to an early green or a red truncation or a green extension based on how that particular intersection is cycled. And really what it is done in the difference between transit signal priority versus other types of preemption technologies is the whole emphasis is not to disrupt the cycle of the intersection, but more keep the cycle intact and just either steal a little bit of green time from an adjacent street or truncate that red as you approach. It's invisible to the average driver, and there are a couple of different ways that you can implement a system so that you can have either a conditional or unconditional treatment Unconditional treatment is the bus is always asking for an extension as it approaches, and conditional treatment is basically there are parameters set into place that would impact when a bus actually asks for specialized treatment at an intersection. I'll get into some of the details of that in a few minutes. And essentially, what is the impact of TSP when we move to the next slide? Essentially, you have a number of different things. These impacts, these percentages and fuel costs and so forth are all, it is basically data that has been developed and based on studies done by the Federal Transportation Administration. So these are not GTP numbers. These are literally numbers that have come from studies. But again, reduced transit delays by up to 40%, reduced bus stop delays by up to 43%. Fuel costs, because you're increasing the speed, you're reducing the fuel cost. Another anecdotal component of that is if you're reducing the speed, you're also, increasing the speed, you're also reducing emissions by as much as 30%. And that improves travel times, which improves on-time accuracy. So these are all the results associated with really implementing TSP. From the deployments that GTP has had throughout the United States and North America, many of these numbers are mapped. Some of these numbers are exceeded, but these are the averages that basically the studies that the Federal Transportation Administration has come up with. The next thing I wanted to talk a little bit about was what are the different types of prioritization? How can you control the requests of TSP? And there's a variety of different parameters that you can utilize, and we have several customers using a number of different configurations of this, but you can actually have requests made only under certain circumstances. It could be a time of day parameter where you only want inbound requests to be made during rush hour in the morning and outbound requests being made in the afternoon, so they can be time of day based, they can be directional based. It also can be limited to specific routes or runs, so that if you have two buses traveling along a similar route, and one is an express bus and one is a local bus, only the express bus will be granted transit signal priority along that route, and the local bus may not be recognized. So there are ways to do it from that perspective. And you can also basically only request when you are late. And how that essentially happens is you can set parameters, a lateness factor. So you can set parameters based on how late the vehicle is, 3 minutes, 5 minutes, 7 minutes. Those types of parameters are set and all configurable and customizable relative to the scenario that you're in. The next slide is a little bit of an eye chart, and Mark and I'll coordinate on how we're going to go through this because there is some animation associated with it. But when you go to the next slide, you're really looking at a diagram that's a building block diagram. And if you look at the first element of it, this is GTT's original technology, infrared technology, that was introduced as long ago as 50 years, as long ago as what we've been in business. And it was a standard point-to-point type of technology that communicated with an intersection. Once the intersection saw the vehicle, then it would request the specialized treatment. About 15 years ago, we introduced the GPS radio-based technology that was that brought into factors like speed and ETA and distance, so you were able to calculate when the vehicle was going to get to the intersection. The important part about that is you didn't have to have extended communication with an intersection starting from 2,000, 1,500 feet away. You could actually have the trigger points be closer to the intersection. And in fact, because it's ETA-based and updating once a second, you could actually change a request to a non-request if the condition changed as you approach the intersection. So if you got up to speed, you wouldn't, or on schedule, you wouldn't request. And if for some reason as you approach an intersection, you lost time, you could turn a non-request into a request. So it gave more intelligence and more information essentially to the system. The other piece as part of this particular phase was adding NTCIP communication capabilities to the traffic controller. As I'm sure most of the folks on this call are aware, NTCIP is a standardized language, or beginning to become a very standardized language in the traffic world. And to be able to communicate via that language versus a standard discrete input-output gives a lot more data to the agency, gives a lot more flexibility to the folks that are communicating to those traffic intersections and traffic controllers. So you end up having a lot more data-rich environment from that perspective. The next step is basically putting information into the cloud, so you're communicating directly from a vehicle up into the cloud and then down to the face selector. What that does is it gives you access to information technology. You get access to all kinds of V2X applications. It becomes a predictable or a way to use a TSP tool as a predictor of traffic, and you can get all kinds of performance analytics out of those types of technologies. So that also is a way of the current infrastructure that's out there can be utilized in that fashion. The next piece is really a centralized solution. That's getting out of the hardware business, getting out of the need to keep adding components to vehicles and intersections, and more into an integrated solution where you have a platform-based smart device on a vehicle, and you have a platform-based smart device either at an intersection or in a centralized location communicating to the intersection like an ATMS system, a traffic management system. So in lieu of needing to put hardware on devices and in intersections, you're actually doing this with software and communications. So no more needing to drill holes in antennas and run wires and find space in cabinets. This is all being utilized, essentially utilizing software. Why that's important? It gives flexibility to the agency, both the traffic agency and the transit agency, to be able to do building blocks with features and solutions and kind of prepare themselves for the direction that other applications are going to be headed. The next element of this is introducing DSRC. Many of you are probably familiar with DSRC, the standardization of a vehicle to intersection and B2B communication platform that's been discussed since 1998, I believe, was the introduction of it. But to us, what DSRC is at GTT, it's another mode of communication. So from our perspective, what we look at is what is going to be your mode of communication? Can we utilize that mode of communication to do applications like transit signal priority, like prioritization of any vehicle? And so that's really how we see it. It's just another method by which we can deliver this solution. And we have actually had successful trials in DSRC. We had a successful trial in 2012, so it predates most of the spam challenge spam challenge initiatives that have gone over the last 2 years. We started implementing in 2012 with that type of utilization. So again, really the purpose of this slide is independent on where you are relative to an agency, relative to a region. It gives you the ability to look at, no matter what my path is, whatever my end game is, GTT's equipment, or whatever equipment you choose, and again, this is the GTT commercial part of this, but whatever equipment you use needs to be backward compatible and understand the infrastructure that's already in place so that you utilize that infrastructure to move forward without having to do forklift changes to your infrastructure. It is critically important with regional transit agencies that travel throughout a variety of different jurisdictions and have technology needs that may be different, or technology legacy that may be different from one jurisdiction to the other. Most of those jurisdictions will fit somewhere into this diagram, and our ability to work and utilize those existing infrastructures and still point everybody in the same direction and get everybody to the same direction of a NTCIP cloud-based solution exists. And so that gives us a unique situation of being able to help you look at your long-term goals, look at your regions and your greater regional areas' long-term goals to get to that end game. Okay. Next slide. Again, BRT standard. It really is, from our perspective, it's essentially to deliver world-class passenger experiences and drive significant economic benefits by getting more people to key locations within a city in a very, very efficient manner. And we truly feel that transit signal priority is a major, major component to that. The next slide, which is kind of why we're here today, there are a handful of BRT systems that meet this ITDP standard, and 3 of the 6 here are GTT deployments. And again, the one I do want to defer to in this particular case is the Albuquerque Rapid Transit, which is considered the one gold standard that has been, it's been identified as the gold standard thus far, and the only one that has received that acknowledgement. That Albuquerque Transit is basically, it's a multimodal migration approach, and I'm going to let Stan talk to it in a minute. But it's a deployment of 28 intersections, 19 buses. They wanted to address issues of bus bunching. Buses were at capacity, and it was too expensive to add buses. So how do you essentially do more with the same or do more with less? And they knew they were facing a major population boom. So the situation wasn't going to fix itself through standard means, and they needed to implement a BRT route with dedicated lanes and utilize offboard some of the standard BRT technologies by introducing new stations, new technology, and so forth. And conditional TSP, so it's a not always on system. It's a system that allows, that's basically coordinated with the time of day and the schedule to ask for TSP when it's necessary. And in this particular case, a faster and more reliable service is going to be enabled by TSP. At this point, been talking fast because I know we're running tight on the time schedule, but I wanted to kind of defer over to Stan to see if he could speak a little bit about this deployment and his role in this deployment, if that's okay with you, Stan. If hopefully your line works. Stan, are you on?
Mark, you're going to have to unmute Stan.
We'll call back in. Yes.
No.
You hear me now?
Stan, you're on now.
There you go. There you go.
Okay.
Thank you. Sorry about that.
So, Craig, feel free to rein me in if I drone on too long. Shall I let you know how we played?
Yes, please do.
All right. I didn't think of the BRT implementation as much different from any other IT project. That is, we needed to feel secure that the software being installed and configured was being done so by folks who knew what they were doing. They had to convince not only us, but the City Central Services Networking Group in order to gain access to the otherwise closed traffic network. We in IT needed to understand the backups, disaster recovery, failover requirements, all the standard sort of back office stuff. But specifically for the TSP, we needed to understand how to ensure that all the parts were working. We needed to come up with a reporting system that could show to those who are relying on the system that all the parts are working as designed. And for those who didn't support the system, we needed to show them that how small an impact on their system it would be. And you referred to both of those things, and that is that whether it's working or not is pretty much invisible to the naked eye, and there is a great concern in TSP that you're going to disrupt the traffic signalization and the timings. So in this particular project, to show our elected officials that each piece of the system was working, and that goes from the bus, in our case, to the server, to the phase selector, to the controller, to the light itself. Once that's done, the scheduler or planner can now begin to create his timings. He can determine the number of buses it'll take to provide the type of service with the headways thereafter, knowing that TSP is providing him with every advantage. We needed to be able to provide the traffic engineers with some numbers to show how many buses pass through the intersection, what percentage of those actually meet the criteria, in our case being late or specific time of day, and what percentage of those requests were actually granted. So there were some of the standard IT concerns and some IT concerns very specific to this project.
Great, Stan. Thank you. Any gotchas along the way? Are there any things that came up during that process that you didn't maybe touch on that are gotchas or surprises?
Aren't there always? We had problems with the buses we ordered. We had to send them back. We had problems with a couple of stations. The road conditions didn't allow the bus to pull up and park in a level condition. So the BRT system wasn't ready to undergo full system testing when we thought it would. We end up with an extremely compressed testing schedule, and we can't wait for the replacement buses to arrive so that we can test the system. What we did is we acquired a bus in a box, which is basically all of the appropriate equipment in a portable box that we put in a car, and we could drive the route to test the system. We were surprised, I think, to find that we didn't have access to the data of the traffic signal controller. In your diagram, you show in each case that the request ends at that controller, and the question is that how do you get the data out of that controller? So we ended up having to deal with the traffic signal engineers and their vendors in order to gather that data. Again, the goal was to be able to ensure that all parties with an interest were advised that every single part of the system was operational and that these requests were being granted when appropriate. And so it was a little difficult to get all of that information that we had hoped. Finally, there's a whole bunch of work to be done once everyone is convinced that all the parts work. There are consultants and folks who determine the placement for that request. As you indicated, as we get further along in our technology, where that request is required in order to trigger the response at the right time, that becomes real important. So there's a lot of work to be done after the IT division is done with it, and you've got to have your IT work completed long enough before the system goes live to allow you to get all the benefits that a BRT system brings you.
Thank you, Stan. One other question I just thought about as it relates to what you were describing is, from your perspective with how your system has been configured, I would assume, and again, I don't want to ask you a yes or no question, but I would assume that the data that's being put out, or the output of the system, is what's going to be utilized in the future to determine how to tweak the system, make it more efficient, identify what other routes potentially it would go on. How important is the data coming out?
It's essential. Again, it may be invisible to the human eye, but for someone who is paying close attention, you can show how much more reliable the buses are, how much more accurate you can, or accurately you can stick to your schedules. And that's going to benefit the riders. The difficulty is, how do you then replicate this? How do you prove it to those who may attribute those benefits to something else? So that's why it's so important to be able to have the data which can objectively present not only the benefits to this route, but the types of benefits that are now replicable across your system. Where is it most important that these types of benefits, with the numbers you now have in hand, can provide the service that you're looking for? And at that point, you can expand beyond a BRT if you're interested. TSP isn't dependent upon that. The concept is, in our world at least, the BRT system is what we will be using to prove the value of TSP.
Excellent. Thank you, Stan. In the interest of time, I'm going to move on, and we'll have a few minutes to ask for those people who can stay a little bit longer. We'll have an opportunity for people to ask questions of Stan and I as we move forward. But in the interest of time, I do want to do the rest of this to get to the Q&A. So some of the other recent deployments in the next slide of BRT system are the lower Hudson Transit link that's utilized up in just outside of New York City, CODA, the CMAX route in CODA, which is also another BRT route, and then CDTA up in Albany has also deployed. There are several BRTs in the works right now throughout North America with global traffic technologies, and the interesting thing about it, as kind of points back to the slide, the building block side, I don't know two systems that are exactly the same. There are a lot of variables. There are a lot of different future visions on how agencies want these systems to be able to interoperate. So there's no two that are the same, and that gives us a lot of experience in being able to work with new partners and really new scenarios. So it is definitely an area that's been growing and so forth for us. From a recap perspective, before we get to questions, actually, you know what? I'm going to stop now and go to questions before we do recap. So if there were a couple of submitted questions during the call and a couple that we received ahead of time. One of them, and I'll read it, in GTT's experience of deploying TSP, what are the biggest issues your customers are identifying? In that, I think one of the, and again, goes back to this building block diagram, BRTs typically are regional in nature, which means they're traversing through multiple jurisdictions, with differing ages of infrastructure and capabilities of infrastructure. So I think the biggest challenge, or one of the biggest comments and questions that we get, is how do you get everybody to the same table on that? And our answer is typically, let's find out what everybody is doing, what infrastructure is in place, what are the different, what's the infrastructure of the vehicles, what's the current infrastructure of the wayside equipment and the city communication system, and what direction is that whole group working in, and how do we put the best solution in place that meets everybody's needs, and does it render one component or one region obsolete? That probably is one of the more common ones. The second common one is BRT route from discussion to implementation is several years. This technology moves very, very quickly. How do you make sure that the conversations you're having relative to technology 3 years ago are going to be still the best way to do it 2 to 3 years moving forward, when that very well may be how long it takes to get the initial BRT route in place or TSP route in place? And our answer to that, and I think that answer is becoming easier for if you have some core elements that you'll understand and you adhere to, and that is the direction is standard communication, standard API type of treatment, or API application. So if your solutions are heading in that direction, you can get everybody to move in that same direction. That typically is the one other question that pops up. That third question we answered. Those were the ones that actually came in. In the interest of, we're a little bit over here now, but I wanted to open up the floor to see if there were any questions of the field, certainly of Stan or myself, that you guys would want to ask.
Craig, we did get a question.
Oh, sorry. So you can put the questions over in the panel on the right. Guys.
We did get a question come in. Do you have experience on corridors with TSP and connected vehicles, and how do they work together?
TSP, it's specifically TSP, and I'm assuming that question is TSP and DSRC. If you're talking connected vehicle and the technology being utilized as DSRC, we have pilots out there where we have where we are utilizing TSP technology, where there are also DSRC or connected vehicle applications in place. That's one question. And again, look, the way we look at it is DSRC is communication from a vehicle to an intersection, but it's also, more importantly, the way it's been designed, or at least most of the applications so far that have been designed are broadcast applications from an intersection sending data out to vehicles. From our perspective, DSRC applications and utilization should be part and parcel to a TSP deployment. Again, that communication, to us, it's just a communication protocol. I can seek out, though, please, whoever asked that question, shoot GTT a message. There are a lot of things going on throughout the United States, and we have several, in North America rather, we have several deployments going on right now. We can probably cite a handful of current TSP or BRT deployments where DSRC and connected vehicle studies are being done side by side. So we'll get you answers to those questions if you're looking for specific areas or specific individuals to speak to.
We had one other question, Craig, and I'm going to have you put on your salesperson hat for this one. What is the average cost per bus? I'm assuming that's related to TSP implementation.
That is about as loaded a question as you can get, and I'll explain why. So if you are looking for a physical hardware, piece of hardware where we're adding a piece of equipment, it can be in the thousands. It can be $2,000 to $3,000 to put a piece of hardware on a vehicle that is specific to a GPS radio-based type of technology. In many cases, however, the infrastructure already exists for the ability to add software. And in a software, you pay for some of that software integration up front, and then it becomes a software application fee over time. So it's a pretty big range. But the great piece of it is we're actually seeing those costs begin to go down dramatically, because when you start dealing with existing infrastructure and you don't have to add pieces of hardware and you can do things from a software environment, that dramatically reduces the cost, number one, down to a vehicle basis, but it also increases your scalability and makes scalability much easier. So, again, there's a huge range there, but there are a lot of specifics, and we can certainly put proposals together for depending on the scenario that the individual has.
Thanks, Craig. That's what we got on the chat line. So if you had any others come in over email for yourself or instant message for you, feel free to answer those. Otherwise, I think we'll probably go ahead and wrap up here.
Okay. All right. Well, I want to thank everybody again. Thanks, Dan, in particular, for joining the call, and I wish we could have spent the entire half hour talking to Dan. I think his information was a lot more valuable. So I appreciate you joining the call, Dan. But any of you have questions, Dan's contact information is here. He is more than willing to discuss with folks that are in similar situations or looking to embark on this path. He's certainly more than willing to discuss how he went through things and ways to streamline the process and so forth. And again, thank you, and reach out to GTT as well. We have several people internally. We have a lot of folks that focus on the wayside side of the business as well as the fleet management side of the business and understand the complexity of the integration between those two things. There's really a lot happening in this space, and again, we're more than happy to answer questions and help smooth out some of the bumps along the way. So thank you very, very much for your time, and please feel free to reach out to us or anybody within the GTT organization.
Craig, this is Stan. Thanks for the opportunity to toot the horn of Albuquerque Transit.
You're very welcome. Thanks, Dan.